Hi there, I am KMD Salman Khan and we'll be taking a look at the majority element problem. So the majority element problem, in this we will have to find the element in a list which appears for more than n by 2 times in that list. So if we have a list of size n, we'll have to find the element which appears for more than n by 2 times. And we can solve this problem in using three different algorithms: the brute force algorithm, the linear time algorithm, and the divide and conquer algorithm. And we'll be seeing how that thing works over here. We first have the size list, which is 10 cubed, 2 times n cubed, 3 times n cubed, all the way to 10 times 10 cubed. Before this was 10 power 4, but it showed that it was running for long periods of time, so I had to scale it back down to 10 power 3. And m is equal to 10 is the number of runs which we will be doing for each of the input size. And here is how it works. We have the BF rec, lin rec, and DC rec. So these will be storing the individual runtimes of each run. So since there are 10 runs, we'll have 10 runtime values for brute force, 10 runtime values for linear, and 10 runtime values for divide and conquer. So to create that input list of size, say 10 power 3, half of them have to be duplicate, right? So we can achieve that using random.seed, and we just append them in that list, and then the second half we just append some random numbers to it. And then I've also shuffled them to make sure it's not as easy for the algorithm to find the majority element. So let me just run them. Yeah, in this case the majority element would be 671. So in brute force, we will be comparing each element in the list with every other element in the list. We will like make a record of the count of each element, and then we just like find if like the count is greater than the majority count, which is n by 2, and we return that value. So this is how we'll be doing it. This is for an individual run. So BF test, which is BF nums, it is calling this brute force function, and then start time. I'm using this to record the time before the program execution, and then I record it again after the program execution called end. And then I just do n minus start, multiply that with 1000, so I can convert that record time into milliseconds. And I've also rounded up that value. So as you see, it did give us the majority element 671 with a runtime of 1 milliseconds. And yes, indeed, the majority element was 671. And the process is the same for like linear time and divide and conquer, where in linear time I use a dictionary, so it's much faster. And then, but this process is entirely the same. See, it's also gave 671 with a record time of 1 milliseconds, and divide and conquer also gave 671 with 4 milliseconds. In divide and conquer, we do like we divide the list into two parts, and then we iterate on them recursively until we find the majority count. But this is where the real experiment is starting. So we have the BF list, lin list, and DC list. So BF list is so these lists will store the average runtimes of each input value. So we have BF rec, which stores the 10 runs, but here we will store the average runtime. And to show this, I think I can pull this thing up for better understanding. So for each size value, we will first create that input value list, and then we will do 10 runs using brute force, and then we calculate the average runtime, 10 runs for linear time, and then calculate average runtime, and same for divide and conquer. So this way the input stays the same for all three algorithms, because these three for loops are inside this for size s loop. So this input value list will be used for brute force, linear time, and divide and conquer respectively. And you can see here, I have already run this thing and it just finished executing. We'll go to the results in a minute. And here's what I'm doing. I have the size s. The first step I did was create the list. I did this part first, and then the same thing. Yeah, I did the brute force for 10 runs. So the same code snippet you saw before, I just put that in a loop, while loop, and did that for 10 times, which is m equal to 10. So I got the recorder time in BF rec. So I have 10 RTs now, and I just calculate the average runtime sum and then round off the BF sum divided by M, which is the average value, and I pen that for BF list. So this entire thing happened for one run. So since this is happening for like all the size list, we will get 10 different average runtimes. And it's the same for linear time, the entire thing, and event conquer as well. And you can see right that over here. I have size 1000, brute force, we have 10 runs, and then linear time for 10 runs, and then divine conquer for 10 runs. And this is only for size 1000. And then for size 2000, we have brute force 10 runs, linear time 10 runs, divine conquer 10 runs, and all the way up to the end. And this is the result which we have. We have